Okay, in this video we are going to look at exponent rules. Here's our first one. X to the a times x to the b equals x to the a plus b. This says that when you have the same base and we're multiplying, you get to add your powers. So if we're talking about x cubed times x to the 7th, this is not going to be x to the 21st, it's going to be x to the 10th. Okay. Likewise, 2 to the 4th times 2 to the 8th. Okay. Be careful here. The answer is 2 to the 12th. It's not going to be 4 to the 12th. A classic rookie mistake is once we throw numbers in here as opposed to variables like an x, a lot of times kids will multiply those bases together. Okay, the base stays the same. Okay, so make sure you don't make that mistake. Okay, base stays the same, add your powers. Okay, our next one here is where we have a power to a power. So we don't have x to a power times x to a power. It's just a single base of x raised to a power, and then that whole quantity is raised to a power. So this rule says that we're going to bring that base of x over, and we get to multiply our powers. So we're not going to add them this time like we saw in the previous one where we had more than one base. So if we have something like x squared, and we'll raise all of that to the 5th power, okay, that's going to give us x to the 10th. It's not going to be x to the 7th, okay, it's going to be x to the 10th. If we have something like 3 to the 4th, and then this whole quantity cubed, this is going to be 3 to the 12th, okay? So we multiply our powers when we have a power to a power, okay? Alright, and finally here, it's possible to have more than one piece raised to a power. So what if we have 2x cubed and all of this is raised to the power of 4? Well, in this situation, we need to distribute the power to each part inside. So you're going to have to do 2 to the 4th, alright, which we know is 16, and then we have a power to a power, so that would be x to the 12th. Okay, so if you have a power on the outside, okay, don't forget you're going to have to distribute that power. It's really 2 to the 1st, okay, that is being raised to the 4th power, okay, so power to a power becomes just 2 to the 4th, so 16. Okay, next rule says that when we have the same base and we are dividing, we get to simplify this by writing that same base of x, and then we get to subtract our powers. So we're talking about x to the 12th over x to the 4th. A lot of times people will think this is going to become x to the 3rd, but this is going to be x to the 8th because you subtract your powers. Okay? Okay, and finally here's one that's a bit tougher. The temptation is to take that 16 and to divide it by 2 and get 8. And then to subtract your powers, okay, but you have to have the same base, okay. Now, you can't always get the same base, however, in this situation, we can get the same base. That 16 is really 2 to the 4th, okay, so we can use some additional exponent rules. So we have 2 to the 12th up above, and then you have 2 to the 12x, and then you have 2 to the x in your denominator. So this is going to become 2 raised to, again, you're subtracting your powers when you have the same base. So we're doing 12x minus x, so that gives us 11x. Okay, so 2 to the 11x would be your answer. Okay, and again, the temptation is to early on to take that 16 and divide it by 2 and call it 8 to the 3x minus x. Well, you can't do that. You need to have the same base. If you go back to your rule up here, okay, you must have the same base before you could then subtract. Okay, next rule is any number, any variable, anything in general raised to a 0 power is equal to 1. So 3 to the 0 is 1. Okay, negative 2 to the 0 is 1. Now be careful when you see things like this. Order of operations says we need to do just 4 to the 0. Okay, that's 1, and then that negative in front would be part of your answer. Okay, if you see 2xy cubed, all of that to the 0, well, that whole thing is 1. But if you see 2xy to the 0 like that, then this would just be 2x times 1, or just 2x. Okay, let's move on to rule number 5. Okay, so this rule deals with a fractional power of 1 over a, and this can be expressed as a root of a surrounding that x, raised to a power of 1. So we're talking about x raised to the 1/3. Okay, that's the same as the cube root of x to the first, or we just say x. X to the 1/2. That's the same as, now we can put a 2 out there, but we call that the square root. We don't ever write the 2. Okay, so a 1/2 power means a square root. Okay, that's really important. You're going to see that used the most. Okay, x to the 1/5, that's the 5th root, of x. So the denominator tells us the root number. Okay, well, what if the numerator is not 1? Well, the numerator simply becomes the power of x. So let's take a look at x to the 2/3. Okay, this would be the same as the cube root of x squared. Okay, what if we were to look at something like 8 raised to the 2/3, and you were expected to find what this is equal to without using a calculator? Well, this is the same as the cube root of 8 squared. So you have an option of doing 8 squared first, getting 64, and then thinking about its cube root. Or it's usually easier to just take the cube root of that base. The cube root of 8 is 2. You're left with 2 squared, which is 4. Okay. Another way of doing this problem is you could say, okay, this 8 to the 2/3, well, 8 is 2 cubed, and then if I take that and raise it to the 2/3 power, notice that if we have a power to a power here, we multiply straight across, these 3's are going to cancel, you're left with 2 squared, or 4. Okay, so you are expected to know how to do things like 8 raised to the 2/3 without a calculator. So whether you use radicals or this technique down below here where you are rewriting that base, okay, doesn't matter. You just need to be able to get an answer of 4. Okay, one more example here. Suppose we have 1 over 27 and we wish to raise that to the 4/3 power. We have to figure this all out without using a calculator. First of all, understand that if we have this 4/3 as a power on the outside, we're going to have to distribute it to each part on the inside. Okay, so if we distribute it, it now looks like that. Alright, and I could technically get rid of these parentheses on the outside here. We don't need it since we've just distributed that power through. Now 1 raised to anything is going to be 1, and then down the bottom here, this 27 raised to the 4/3. You could say, alright, this is going to be the cube root of 27 to the 4th. Well, without a calculator, you're not going to want to do 27 to the 4th and then try to cube root it. Instead, it's easier to say, okay, what is the cube root of 27? Alright, if this is no calculator, you're going to have nice integers. So the cube root of 27 is 3, so we're left with 3 to the 4th, which is going to give us a final answer of 1 over 81. Now, in regards to this piece right here, this 27 to the 4/3, the other option is to say, okay, 27, that is 3 cubed. And then we have that power of 4/3. From there, like before, these 3's will cancel, and you'll still get that 81 that we saw before. Okay, and finally here, our last rule deals with a negative power. So x raised to the negative a is equal to 1 over x to the positive a. So this says take that negative, go ahead and make it positive, but make sure you do 1 over it. So we're talking about x to the negative 3. That's the same as x to the positive 3. Or 3 to the negative 2. Alright, this is not negative 6, it's not negative 9, it's 1 over 3 to the positive 2, which is 1 over 9. Okay, things like 4 to the negative 1 always mess people up. People think this is negative 4. It's not. It's 1 over 4 to the positive 1, which is just 1 over 4. Okay? Now, this works the other way, too. Suppose you have something like 1 over 4 to the negative 5. Well, you can bring up that 4 to the negative 5 up to the top, so you'd have 1 times 4 to the positive 5. All right? If you have 3 over 4 to the negative 2, that's the same as 3 times 4 to the positive 2. Okay? If you have 7 over 2y to the negative 3, we need to be careful here. Only that y to the negative 3 can come up, so you'd have 7y to the positive 3, and then that 2 stays in the bottom. Sure, you can turn that into 3.5, okay, y cubed, but the negative 3 in this case only belongs to the y.